It waits in silence, perched on a mountaintop, or drifting beyond the pole of Earth. The telescope stares into the endless night. Its mirrors do not seek beauty. They are tuned instead to the faintest whispers of the cosmos, the fragile glow, left behind by the birth of everything. But within that ancient light, something impossible emerges. Not stars, not galaxies, not even voids. What the telescope sees are absences, dark imprints woven into the very fabric of the cosmic afterglow, as if something vast once stood there, long before light had a chance to exist. A shadow without a source, a bruise on the first canvas of creation. The question presses like a weight against the mind. What could cast a shadow before there was light to block? For centuries, the universe's beginning seemed clear. The Big Bang, a singular eruption of energy and time itself, 13.8 billion years ago. But these imprints carry the unsettling suggestion of something older, something that preceded the beginning. If true, the implications ripple outward like shockwaves. Creation may not have been a birth, but a boundary, a veil drawn over an older order, one the cosmos still remembers in scars faintly etched across the sky. The telescope's vision is undeniable. The shadows exist, and they whisper of a truth that should not be possible, an echo from before the first dawn, a challenge to the very foundations of cosmology. The universe, it seems, holds memories older than itself. Chapter 1: Discovery Phase. The story of these ancient shadows does not begin with a single telescope. It begins with a sound. In 1965, two young radio astronomers, Arno Penzias and Robert Wilson, climbed into the horn-shaped antenna at Bell Laboratories in New Jersey, searching for the source of a stubborn hiss that haunted their experiments. They cleaned the instrument, swept away nesting pigeons, even scraped the droppings from the cold metal. Yet the hiss remained, uniform and relentless. It came from every direction in the sky, never fading, never shifting. What they had stumbled upon was not noise at all, but a whisper from the beginning of time. This faint radiation, later named the cosmic microwave background, or CMB, was the afterglow of the Big Bang itself. A fossil light, stretched and cooled over billions of years, still bathing the cosmos like a silent memory of creation. With that discovery, the universe revealed its first photograph, a sky glowing evenly like the dying embers of an ancient fire. For the first time, cosmologists held evidence that the Big Bang was not a theory alone, but a real event, still echoing through every corner of the heavens. Decades later, new satellites rose above Earth to map this light in sharper detail. The COBE satellite, launched in 1989, painted the CMB with unprecedented clarity. In its data, scientists saw tiny fluctuations, subtle ripples in temperature that betrayed the seeds of cosmic structure. These were the fingerprints of galaxies. Before galaxies, the first faint irregularities in a universe that began almost perfectly smooth. Then came WMAP in 2001, orbiting far beyond the interference of Earth. It delivered a higher resolution portrait of the cosmic afterglow. The universe was revealed not as flawless, but as patterned tiny speckles and blotches, no more than a few millionths of a degree hotter or colder than the rest. These fluctuations, scientists realized, were the blueprint of everything that exists. Without them, galaxies would never have formed. Finally, in 2009, the Planck satellite was launched by the European Space Agency. With exquisite precision, it traced the faint variations across the entire sky. Its measurements allowed cosmologists to calculate the universe's age, 13.8 billion years, with extraordinary accuracy. It mapped the density of matter, the strength of dark energy, the shape of space itself. And yet, amid this triumph of clarity, there were scars that refused to fit. When researchers processed the Planck data, they noticed irregularities that resisted explanation. The most famous was a vast, cool blotch in the southern hemisphere of the sky, known simply as the cold spot. It was larger than any natural fluctuation, should be stretching across hundreds of millions of light-years. Too large, some argued, to be explained by random chance. It was here that the mystery deepened, because within this cold spot and across other faint patches of the CMB, patterns emerged that looked less like random noise and more like shadows, subtle, darkened regions, as though something enormous had once pressed against the young universe, leaving behind a bruise. The shadows were not obvious to the eye, but the data was insistent. The CMB should be nearly uniform, its small fluctuations well understood. Yet these darker regions hinted at something unaccounted for, an influence not born from within the universe, but perhaps from beyond it. Some scientists proposed ordinary causes. Perhaps the shadows were the result of supervoid cements, empty regions of space that distort background light as it passes through. Others suggested they were artifacts of measurement, statistical flukes that appeared significant only by chance. But as the data grew more precise, the anomalies did not vanish. Instead, they persisted. The shadows remained etched into the oldest light we could see, stubborn against the erasers of error. To map them was to peer at the very threshold of creation, where physics itself trembled under the weight of uncertainty. For if these patterns were real, they could not have been cast within the universe as we know it. They would belong to something older, something that reached across the veil of the Big Bang and left its mark upon the newborn cosmos. The telescope, designed to capture the universe's first light, had instead glimpsed the first darkness, and in that darkness lay a paradox that shook the foundations of cosmology. Shadows imprinted before there was light to cast them. The scientists, careful and cautious, called them anomalies. Yet beneath the clinical language, unease lingered, because hidden in those faint bruises of radiation was a possibility almost too vast to face. The possibility that the Big Bang was not the beginning, but merely the opening act of a story far older than creation itself. The discovery phase was complete. The shadows were real, and their presence demanded explanation. Chapter 2: Scientific Shock. The cosmic microwave background was meant to be the clean slate of creation, a veil of light stretched across the sky, uniform, ancient, and untouchable. According to the standard model of cosmology, nothing should stand behind it. Beyond the CMB lies opacity, a universe so hot and dense that light itself could not yet travel. In theory, this was the boundary wall, the first visible surface of time, and yet the data suggested otherwise. When researchers studied the Planck maps in painstaking detail, they found not only the familiar ripples, those delicate variations that seeded galaxies, but patterns that seemed alien to the model. Darker blotches, colder patches, shadows that looked as though they had been pressed into the afterglow from some unseen hand. The shock was immediate. The CMB was supposed to be pristine. It was the first light, a record of the moment the cosmos became transparent. 380,000 years after the Big Bang. Nothing before that moment should have left a trace. And yet these scars looked older. It was like examining a freshly painted wall and finding fingerprints beneath the paint itself. If the paint was creation, what could have touched the surface before it even existed? The analogy haunted cosmologists, because to accept these shadows as real meant to accept that the universe carried memories from before its supposed birth. The cold spot became the most unsettling of these anomalies. Its sheer size defied expectation, according to the statistics of inflationary cosmology. Fluctuations should fall within certain predictable limits. This one did not. The odds of such a feature appearing by chance were vanishingly small. It stretched like a bruise across hundreds of millions of light years, colder than its surroundings by more than theory allowed. If it were merely a void, region of lower density that sapped heat through gravitational effects, it would need to be larger than any void observed. And even then, simulations showed the void could not explain the full depth of the anomaly. The Planck team, cautious by training, considered possibilities: instrumental error, statistical illusion, the universe playing tricks in random noise. But year after year, reanalysis after reanalysis, the shadows remained. Each new telescope, each refined dataset, confirmed that these anomalies were not erased by clarity. They grew sharper under scrutiny. The shock lay not only in their persistence, but in their implication. For if something had left its mark before the surface of last scattering, before light escaped its primordial prison, then the Big Bang was not a true beginning. It was merely a threshold. Such an idea unsettled the foundations of modern cosmology. The Big Bang was not only a model, it was a narrative, the story of everything, a universe with a beginning, an origin point in time. But the shadows hinted at influences older still, echoes from a realm that should not exist. Some scientists whispered of cosmic prehistory events that preceded the Big Bang, pressing faintly through the fabric of the CMB. Others suggested that the anomalies were signs of interaction between universes, collisions between bubbles in the foam of cosmic inflation. But the philosophical weight of the question pressed hardest. If the CMB is the first light, how could anything stand behind it? To find shadows older than light is to confront a paradox. The universe was supposed to begin in an instant of singularity, when all space, matter, and time erupted together. Nothing came before, because time itself had no before. Yet the CMB seemed to carry scars of an earlier influence, like ghosts pressing against the curtain of existence. For cosmology, this was no small disruption. It was not merely a puzzle of measurement, but a challenge to meaning itself. Either the shadows were illusions, sartifacts conjured by noise, or the universe was whispering truths that defied its own origin story. Scientists were shaken, torn between skepticism and awe, for in these faint, darkened imprints, the cosmos seemed to be speaking from beyond creation. Chapter 3: Deeper Investigation. The cold spot was not an answer. It was an invitation, an opening into a labyrinth of deeper questions. For years, the anomaly had lingered in the data, dismissed by some as a statistical trick, embraced by others as a possible wound carved into the universe itself. But the longer telescopes gazed, the less dismissible it became. With each refinement of the cosmic map, with each subtraction of noise and error, the shadows grew sharper, not softer. The Planck satellite, with its unprecedented sensitivity, painted the clearest portrait of the cosmic microwave background. And there, sprawling across a vast region of sky, lay the cold spot, hundreds of millions of light-years across, colder than surrounding space by nearly 70 microkelvin. It was not just unusual, it was profoundly improbable. The odds of such a feature appearing by chance within the framework of inflationary cosmology were estimated at less than 1%. At first, scientists sought refuge in the ordinary. Perhaps the cold spot was nothing more than an immense region of near emptiness through which light had passed and been subtly drained of energy by the integrated Sachs-Wolf effect. The void would act like a cosmic desert, robbing photons of vitality as they journeyed across it. But as surveys probed deeper into the region, no void of sufficient scale appeared. The emptiness was real, but not nearly vast enough to explain the anomaly. The numbers refused to align. The anomaly persisted, growing stranger in context, because the cold spot was not alone. When cosmologists examined the full sky maps of the CMB, they noticed alignments subtle but unsettling. Temperature fluctuations seemed to orient themselves along preferred directions, as though the universe itself bore a faint axis, a cosmic fingerprint, inconsistent with perfect randomness. This became known as the axis of evil, a name born half in jest, half in dread. The axis stretched across multipoles in the CMB's spherical harmonics, linking patterns that, under standard theory, should have been uncorrelated. It was as though some immense brush had swept across spacetime, leaving streaks in what should have been chaotic noise. Patterns such as these whispered of forces not accounted for, a cosmos sculpted not only by quantum chance, but by influences that pressed from beyond its visible edge. It was here that speculation deepened into the profound. Some physicists began to speak of cosmic bruises, scars left behind when our universe, still in its infancy, collided with others. According to the theory of eternal inflation, our cosmos is but one bubble in an infinite froth of universes, each expanding, each with its own laws and constants. If two such bubbles brushed against one another in their birth throes, the collision might leave a mark, not a visible object, not a tangible structure, but a bruise in the background radiation, etched permanently into the sky. The cold spot, with its improbable depth and scale, seemed to fit this description. Could it be evidence of another universe, pressing against our own like a shadow through thin fabric? Others turned to an even more enigmatic possibility: primordial black holes. Unlike the monsters formed by collapsing stars, these would have been born in the first instance after the Big Bang condensations of density so extreme that gravity overwhelmed expansion. If such entities existed, they could have imprinted distortions upon the plasma before light was free to travel, leaving scars later visible in the CMB. Invisible then, but not forgotten. The notion was chilling. To see their mark would be to glimpse objects older than light itself, fossils of gravity from an age when the universe was less than a heartbeat old, and yet the shadows resisted singular explanations. Every hypothesis, no matter how daring, seemed incomplete. A void was too small, a bruise too speculative, a primordial black hole too elusive. The anomalies multiplied, each refusing to bow to clarity. Statistical oddities appeared where none should be, hemispherical asymmetries, cold and hot spots arranged with eerie persistence, alignments that defied randomness. The deeper scientists peered into the cosmic afterglow. The more it appeared touch-shaped by some hidden hand, the shock of discovery had given way to the weight of implication. If the universe bore scars, they were scars of events unseen, unreachable, older than physics itself could yet describe. In hushed conference halls, cosmologists debated with caution. Was this the signature of a multiverse, glimpsed not in theory, but in the faintest shadows of the sky? Was it the fingerprint of forgotten matter structures or dimensions that coexisted with the birth of time but left only echoes? Or was it a cruel trick of probability, a reminder that even the largest datasets harbor flukes? Each explanation carried not only scientific tension but philosophical weight. To prove a void was to reaffirm structure within chaos. To prove a bruise was to redefine reality itself. For if our universe had collided with another, then the cosmos was no singular story. It was an ocean of beginnings, infinite in scope, boundless in possibility. And what we called creation was not unique, but one among countless others, leaving and receiving scars in an eternal dance of universes. The telescope had been built to measure the oldest light. Instead, it had uncovered the oldest wounds, and still the investigation deepened. Each attempt at resolution only revealed further strangeness. Each map of the heavens seemed to suggest a cosmos less random, less simple than theory allowed. The universe, far from being a smooth canvas of chance, looked increasingly like a tapestry woven, aligned, scarred, and shaped by influences it refused to reveal. In the shadows of the first light, scientists found not closure, but the unsettling suggestion of something vast brushing against space-time itself. Something that should not be there, something that should not exist, and yet it does. Chapter 4: Escalation. Mystery deepens. The longer the universe was observed, the more it betrayed its own secrets. When the first anomalies appeared in the microwave sky, many believed they would dissolve under sharper scrutiny. Noise would fade, instruments would improve, and chance alignments would be erased by clarity. But the opposite occurred. The anomalies did not vanish. They grew sharper. Each refinement of the data, each recalibration of the instruments, stripped away excuses. What remained were scars that seemed too deliberate, too persistent to be dismissed. The cold spot endured. The axis of evil aligned. Hemispherical asymmetries stretched across the heavens, refusing to yield to randomness. The more cosmologists studied these patterns, the more disturbing their implications became, for they suggested that the Big Bang, the grand eruption that had long been considered the beginning of time, was not an origin at all. It was a threshold, a surface draped across something deeper, stranger, and older. If this was true, then the shadows imprinted on the cosmic microwave background were not remnants of chaos within creation, but echoes of realities before it. The Philosophical terror of such an idea was profound. For centuries, science had sought to trace existence to a first cause, a singularity where time and space were born. To imagine that the Big Bang was not the dawn but merely a veil, that the true past stretched further still, was to confront an infinite regress. A universe without origin, or worse, a universe born from something it could never remember fully, yet never escape. Radical possibilities began to take shape. One was the vision of conformal cyclic cosmology, championed by Roger Penrose. In this, model universes are not singular, but sequential. Each universe lives, expands, and dies, fading into a cold eternity, where black holes evaporate into silence. Yet the death of one cosmos becomes the birth of another. The imprint of that death may leave rings, bruises, and shadows upon the next. The cold spot itself, Penrose suggested, might be the echo of a black hole evaporating in a universe that existed before ours. A shadow not of absence, but of presence, evidence that our cosmos was not first. Others envisioned collapsed, hidden dimensions pressing against the fabric of our own. In the theories of string cosmology, our universe could be a brain floating within a higher dimensional reality. A collision between brains could have ignited the Big Bang. The shadows imprinted upon the afterglow as the scars of contact. If so, the cold spot might not be a wound, but a pressure point where another dimension once pressed close against our own. Some considered multiverse collisions during inflation. If the early universe was a froth of bubbles expanding in eternal inflation, then our cosmos was only one of many. A neighboring bubble might have brushed against ours, leaving behind the faintest scar, cosmic bruise, visible only in the oldest light. In this picture, the cold spot was not an error, but the footprint of another universe. But the possibilities grew darker still. Perhaps these shadows were not absences at all, but presences, gravitational structures so vast they preceded light itself, primordial black holes of unimaginable scale, or relics of a pre-Big Bang state of matter. These structures, though invisible to radiation, could warp spacetime in ways that left an indelible mark on the CMB. Their shadows would not fade, because they were not illusions. They were fossils of an era before physics as we know it. The narrative escalated with every discovery, with every careful reanalysis. What began as noise became signal. What began as doubt became unease. The universe was not smooth, not entirely random, not the simple child of a singular birth. It bore wounds, it bore alignments, it bore memory. And this memory carried a terrifying weight. For if shadows older than creation exist, then creation itself is not a beginning. It is a curtain pulled across something that lies beyond. A mask covering a face too vast to see. Scientists, bound by caution, called them anomalies. But anomalies do not sharpen with clarity. They do not align across scales. They do not endure against every attempt to erase them. What lingered in the maps of Planck, WMAP, and COBE were not random stains, but fingerprints, footprints pressed against the first light, belonging to something unknowable, something outside the reach of theory. And so, in quiet offices and observatories, a realization grew like a shadow itself. These anomalies might not simply be curiosities of data they might be the first evidence of something beyond cosmology, the cold spot, the axis of evil, the hemispherical divide. Each one was unsettling in isolation. Together, they formed a chorus, a whispering that the universe was not born clean, but born scarred. The implications stretched beyond science into philosophy itself. What does it mean for humanity if the universe has memories older than time? What does it mean if creation was not creation, but inheritance? In the silence of the night sky, the telescope continued to watch. Its mirrors reflected not stars, but shadows. Shadows that deepened with every measurement. Shadows that spoke of collisions, of echoes, of dimensions unseen. Not absences, but presences. Not illusions, but imprints. Not data, but footprints left by the unknowable. And so the mystery did not fade. It sharpened, it darkened, it grew into a wound that science could not yet close. The universe, it seemed, was not only stranger than imagined, it was older than believed. Chapter 5: Theories and Speculations. When the shadows refused to fade, when the marks upon the cosmic afterglow sharpened instead of vanishing, scientists could no longer dismiss them as noise. They were forced to turn toward theory, to the wild frontier where mathematics brushes against philosophy, and imagination dares to touch the edge of truth. One by one, ideas were raised, some elegant, some unsettling, none complete, all haunting inflationary bruises. In the earliest fractions of a second, the universe expanded faster than light itself. This event, called cosmic inflation, smoothed the newborn cosmos into near uniformity. But inflation has consequences. In many versions of the theory, inflation does not end everywhere at once. Instead, it creates a multiverse, a sea of expanding bubbles, each one a universe, forever inflating into the void. In this cosmic foam, collisions are inevitable. Just as soap bubbles brush and merge, universes may touch, leaving scars at the site of impact. The anomalies etched into the cosmic microwave background fit the pattern of such collisions. A cold bruise, like the cold spot, could be the lingering trace of another universe's passing. Its gravitational fingerprint, frozen into the first light. The mathematics suggests that such a collision would create circular patterns, subtle alignments, hemispherical asymmetries, the very shapes astronomers now debate. If these shadows are bruises, then the universe is not alone. It is one bubble among countless others, and what the telescope sees is the scar of contact. But this theory carries both awe and dread, for if true, it means our universe is not complete in itself. It was born within a larger inflating sea, its boundaries fragile, its history entangled with others. The bruise is not just a mark. It is a reminder of a vast and unseen neighborhood, where universes are born and collide like waves upon an endless ocean. Primordial black holes. Another possibility reaches back even further, to the very first instance of time. In the chaos following the Big Bang, density fluctuations rippled through the infant cosmos. Where these fluctuations were extreme, gravity may have triumphed, collapsing regions of energy into primordial black holes, objects older than stars, older than galaxies, older than matter itself. Unlike the black holes known today, born from the deaths of stars, these would be fossils of creation. They could be as small as mountains or as vast as millions of suns. Their gravitational pull would warp space-time, bending the light that later swept across the cosmos. If such ancient wells of gravity existed, they could have left their fingerprints on the microwave sky. Their invisible weight could stretch the fabric of the afterglow, carving subtle depressions, faint shadows where light lost its way. The possibility is not merely speculative. Some astronomers suggest primordial black holes might even make up the mysterious dark matter, the invisible mass outweighing all stars and galaxies combined. If so, the shadows are not just curiosities, they are the signatures of the universe's hidden skeleton, the dark bones of creation itself. Yet the danger of this idea is its scope. For to believe that black holes existed before matter, before light, before atoms, is to accept that gravity itself is older than the universe we know, that the first structures were not galaxies, but a BYSSES. If the shadows are their work, then the universe did not begin in light. It began in darkness, conformal cyclic cosmology. Perhaps the strangest vision came from Roger Penrose, Nobel laureate and architect of mathematical cosmology. He imagined time not as a line with a beginning, but as a cycle of infinite succession. In his conformal cyclic cosmology, universes do not die into silence, they transform. Over unimaginable eons, every black hole evaporates, every particle decays, and the universe thins into pure radiation. In such a state, without scale or mass, the death of a cosmos becomes indistinguishable from the birth of another. The end of one eon bleeds seamlessly into the beginning of the next. If Penrose is correct, our Big Bang was not the first, it was a rebirth, and the shadows etched into the microwave background may be the evidence, rings and bruises marking the places where black holes died in a universe that came before. These are not random stains, they are scars of ancestry, imprints of an elder cosmos pressing its memory into the fabric of the next. The idea is both comforting and terrifying. Comforting because it rescues the universe from a singular beginning, offering continuity where none was thought to exist. Terrifying because it suggests eternity without origin, a cycle without escape. The shadows are not whispers from beyond the Big Bang. They are fossils of universes that lived and died long before ours. Holographic echoes. Then comes the most unsettling speculation of all, the possibility that the universe itself is not what it seems. The holographic principle, born from the physics of black holes, suggests that the three-dimensional cosmos may be a projection from information encoded on a distant boundary, reality. As we know, it would then be a kind of image, a shadow cast from deeper laws. If so, the irregularities in the cosmic microwave background might not be cosmic at all. They might be artifacts of projection, glitches in the code that generates the world. The shadows would not be scars from collisions, nor fossils of black holes, nor bruises of past universes. They would be echoes, reflections of the deeper dimensional fabric from which reality emerges. In this interpretation, the cold spot and its kin are not anomalies in space. They are windows into the machinery of existence. But this explanation is the most disquieting of all, for it strips reality of solidity. It tells us that what we see, touch, and measure may be a surface, an illusion with rules written elsewhere. To stare at the CMB would then be to glimpse the scaffolding behind the stage of being. The shadows are not wounds. They are fingerprints of the code. Unfinished answers H theory, issues. Each carries a poetry of its own. Universes colliding. In a sea of inflation, black holes older than time, cycles of birth and death, endlessly repeating. A holographic reality flickering on the edge of dimensions, unseen. And yet, each leaves questions unanswered. No explanation is complete. No theory fits every anomaly. Perhaps all are partly true, perhaps none. What remains certain is this: the shadows refuse to vanish. They linger, stubborn, etched into the first light. They mock the idea of a clean beginning. They whisper of histories unknown, of structures unseen, of laws not yet written into the textbooks of physics. For every attempt to explain them, they slip further from certainty, deeper into mystery. Like footprints found on the shore of an ocean at night, they prove only one thing beyond doubt: that something vast has passed here before. And so the universe remains unfinished. Its oldest light carries questions more haunting than answers. Questions that force humanity to confront the possibility that creation was not singular, not absolute, not final. The shadows, in their silence, tell us that the story of the universe is larger than the universe itself. Chapter 6: Scientific Tools and Ongoing Testing. The shadows lingered, etched into the map of the oldest light. To confront them, humanity reached for its most delicate instruments, machines capable of stretching sight and hearing into realms where no eye or ear could go. What began as a faint anomaly soon became a quest, a pursuit across the heavens, a silent chase for traces of what might have existed before creation itself. Eyes in the sky. The story of this chase begins with telescopes that were not made to gaze at stars, but to read the afterglow of time. First came COBE, launched in 1989, whose maps of the cosmic microwave background confirmed what Penzias and Wilson had stumbled upon decades earlier. Its data revealed fluctuations so faint they were measured in millionths of a degree, tiny seeds from which galaxies would grow. But hidden in the background noise were patterns that did not entirely fit. Then came WMAP in 2001. Its sharper vision refined the age of the universe to 13.8 billion years. It saw the asymmetries more clearly, patches that stretched across the sky, too vast to be the work of galaxies, too ordered to be mere chance. Finally, the Planck satellite, launched by the European Space Agency in 2009, brought the most detailed map ever created of the early universe. With a precision unmatched, Planck unveiled the infamous cold spot, a region of sky hundreds of millions of light-years across, darker and colder than any structure should allow. The cold spot was not a starless void, it was something stranger, a blemish pressed into the fabric of space-time itself. Each telescope sharpened the image, each stripped away layers of doubt, and yet, with every improvement, the shadows did not fade, they deepened. The ground-based sentinels above Earth, satellites, saw the patterns. On Earth, instruments sought to test their meaning. The BICEP experiments, stationed at the South Pole, turned their lenses toward the CMB, not just for its temperature, but for the subtle twists in its polarization, the curling fingerprints that gravitational waves from the dawn of time might leave. If inflationary bruises were real, if universes had collided, The swirls of polarization would be the scars. Biceps data hinted at something extraordinary. In 2014, headlines spoke of gravitational waves from inflation, but dust ordinary, interstellar. Dust clouded the result, reminding humanity of the fragility of its vision. The signal evaporated under scrutiny, yet the pursuit did not end. Even now, successors, Bicep 3, the Keck array, and planned experiments like CMBs foreseek the same delicate patterns, building instruments with ever greater sensitivity. The goal remains unchanged: to find, within the static of the microwave background, the tremors of a universe older than the Big Bang. The infrared frontier, though designed for stars and galaxies, the James Webb Space Telescope has become an unexpected player in this search. Its infrared eyes peer back to the first galaxies, to the faint glimmers formed only a few 100 million years after the Big Bang. And yet, Webb has already unsettled expectations. It has found galaxies larger, brighter, and more mature than models predicted at such an early epoch. For some cosmologists, these discoveries hint that the foundations of the Standard Model may not be as firm as once believed. If galaxies formed earlier than expected, what else might have existed before light itself? Webb cannot see the microwave background, but it sharpens the context, painting the structures that rose in the wake of the shadows. Each discovery reopens the question: did the marks in the CMB shape the cosmos we now observe? Future messengers, light Bayard and beyond, in the coming decades. New satellites are being built to press the mystery further. Japan's Light Bayard, scheduled for launch in the 2030s, will map the polarization of the CMB with exquisite precision, far beyond Planck. It will not look for galaxies or stars. It will look for whispers, subtle imprints in the afterglow that could confirm inflation's multiverse bruises or rule them out forever. Other missions, like CMB's 4 and Europe's core proposals, envision constellations of detectors across Earth, in orbit, each tuned to hear the faintest murmurs of creation's opening act for humanity. These machines are not merely telescopes. They are instruments of memory, built to listen for echoes of events that occurred before time had meaning. The subatomic Searchwhile telescopes stretch across the sky. Other experiments burrow into the fabric of the very small dot at CERN's Large Hadron Collider. Particles are smashed together at near-light speeds, recreating conditions a trillionth of a second after the Big Bang. Among the wreckage, physicists seek particles that could explain the shadows, candidates for dark matter, fields from inflation, signatures of extra dimensions. The Higgs boson, discovered in 2012, confirmed the mechanism that gives particles mass, but it also raised questions. Could the Higgs field be linked to inflation itself? Could its quantum fluctuations, in the first instant, have imprinted scars into the microwave sky? Other experiments, buried deep underground in mines and mountains, listen for the silent collisions of dark matter. If primordial black holes or exotic particles shaped the early cosmos, their remnants might still haunt the present. Each detection attempt is a plea, a reaching into the darkness for an answer. Gravitational waves, echoes beyond light. Perhaps the most profound hope lies not in light at all, but in ripples of spationy. In 2015, LIGO announced the first detection of gravitational waves distortions caused by merging black holes billions of light-years away. Since then, dozens of such events have been recorded, each a faint vibration passing through Earth. But what if detectors could hear older waves, not the songs of black holes and neutron stars, but the whispers from the universe's first heartbeat, a primordial background of gravitational waves generated during inflation would carry information older than the microwave background itself. They would be messengers from a time when light did not yet exist. Future observatories, Lisa, in space, pulsar timing arrays spread across galaxies, even atominterferometer detectors on Earth aim to tune their ears to these ancient tremors. If found, they could confirm whether the shadows are the bruises of colliding universes, or the signatures of pre-Big Bang physics written directly into spacetime. Such a discovery would not be seeing. It would be hearing the universe before it had eyes. The paradox of progress, and yet the deeper humanity looks, the stranger the picture becomes. Each new observation narrows possibilities, but also opens new contradictions. Planck confirmed the cold spot, but could not explain it. Webb revealed early galaxies, but unsettled cosmological models. Particle accelerators confirmed the Higgs, yet deepened the puzzle of inflation. That the instruments grow sharper, the shadows remain. It is as though the universe reveals itself in fragments, giving glimpses, but never the whole. The closer the machines approach, the more the horizon retreats, listening for the before in deserts and mountains, in orbit and beneath the Earth. The arsenal grows. Telescopes stretch toward the beginning of light. Colliders hammer at the bedrock of matter. Detectors vibrate with the faint songs of spacetime. Together, they form a single chorus, a human attempt to listen beyond creation, to hear the whispers of what, if anything, existed before the dawn. But even as the data accumulates, the paradox persists. For every answer, a deeper question. For every shadow explained, a darker one emerges. The machines are not only tools, they are mirrors of longing, built from the unspoken desire to know whether the universe is complete or whether it hides a history older than itself. And so humanity continues to build, to wait, to listen. Machines tuned to silence, eyes fixed on absence, ears pressed against the void. What they seek is not light, but the trace of what stood before light. A signal older than beginnings, a memory the universe has not yet forgotten. Chapter 7. Philosophical Reflection. Emotional Close. At last, the trail of data and theory reaches silence. The instruments hum, the numbers accumulate, the equations remain unfinished, and beyond them lies the question that science alone cannot answer. For if shadows older than creation truly exist, then the word creation dissolves into mist. The Big Bang is no longer the first note of the cosmic symphony. It is only the rising curtain, revealing a stage that was already there. The illusion of beginnings. Humanity once believed the universe had a simple story, a beginning, a middle, an end. A line stretched from nothingness to existence, from origin to destiny. But the shadows suggest otherwise. They whisper of a canvas stretched wider than time, where beginnings are not absolute, but relative. Where what appears to be the first spark may only be a flicker in a longer fire. The Big Bang, once thought to be the dawn, may be only a boundary, a membrane across which memory from an older order has seeped, like a veil, thin but luminous, hiding something immeasurably ancient. If so, then time itself is not a river with a source, but an ocean without shore, and every attempt to name a beginning is like tracing a wave back to its origin, only to find it born from countless others, stretching endlessly into the dark. The weight of perspective to stand beneath this revelation is to feel small, for the human mind, accustomed to edges and borders, struggles before infinity in both directions. If the universe has no singular origin, then its scale cannot be measured in ages or epochs. It is eternal, not in a forward sweep alone, but backward as well. Existence itself becomes unmoored, suspended between cycles, collisions, echoes, and shadows. What does it mean, then, that fragile beings of dust and carbon can even ask these questions? That machines of glass and silicon can touch the afterglow of eternity? The greatest astonishment is not only that the universe hides its history in light, but that human minds are able to read its script. The telescope as witnessing mountaintops, and in orbit the telescopes continue their quiet vigil. Their mirrors drink the ancient light, not with eyes, but with patience. They measure photons stretched thin across billions of years, whispers traveling farther than any voice, and as they gaze, they become more than machines. They are witnesses. Witnesses not just to galaxies and stars, but to the silence between them, to the scars and shadows that reach across time. Each instrument is a question given form. Each signal received is an answer half hidden, and still they look. Echoes of eternity. The greatest mystery may not be what cast the shadows, nor whether they came from other universes, primordial black holes, or forgotten cycles. The deeper mystery is why the universe allows them to be seen at all. Why does the cosmos reveal its scars when it could have concealed them forever? Why does it let fragile creatures glimpse truths that reach beyond creation itself? Perhaps the shadows are not evidence alone. Perhaps they are invitations, a gesture from the infinite to the finite, saying, "Look closer." In that gesture lies both wonder and humility. For if humanity can see the fingerprints of eternity, then humanity is also part of that eternity, however small, closing image, and so the telescope remains, silent, patient, unblinking. It gazes not only into the past, but into the mystery of existence itself. Its mirrors hold the reflection of shadows older than time, while its instruments wait for whispers yet unheard. It does not know what it sees. It only listens, and in its silence it reminds us the universe is not a story with a beginning. It is a presence, vast and unending. The shadows are not endings nor beginnings. They are echoes of eternity, proof that the cosmos is larger than comprehension, and that to witness even its faintest trace is a privilege beyond measure. Final reflection. The universe does not owe humanity clarity, yet it grants glimpses, not certainty, but mystery. And perhaps that is enough. For, in the end, the wonder is not in solving the shadows. The wonder is that they are visible at all.